A field wind shear testing instrument shown in this figure was inserted completely into a deposit of soft saturated silty clay with the vane rod vertically such that the top of the blades were 500 below the ground surface. Suppose this is the ground surface. See, total vane shear blades, these are the vane shear blades, they are well below the top of the soil ground level, you can say. So this is 500 mm. Okay, upon the application of the rapidly increasing torque about the vane rod, the soil was found to fail when the torque reached 4.6 Newton meter. Assuming mobilization of undrained shear strength on all failure surfaces to be uniform and the resistance mobilized on the surface of the vane rod to be negligible, what would be the peak undrained shear strength rounded off to the nearest integer value of kPa of the soil? So this question is from the GATE 2011 civil engineering paper of 2 marks. So first of all, what is vane shear testing instrument? See, vane shear testing machine does have one rod and four blades like this, you can say. Okay, see, you have to insert this total assembly into the soil. Okay, suppose like this. If you see the from the front, you can see only these two blades, let us say. So then you have to rotate this rod. Okay, when you rotate this rod, then the soil which is encapsulated in this, that will rotate and it will fail in circular shape. So finally, due to application of the torque T, it will fail. So by taking the torque value whenever it is failing, so you can find out the shear strength value of the soil. So now, taking this concept, uh, we will first note down the given data. Okay, let us note down the given data. It is well below the ground level. So that is one thing. Upon the application of rapidly increasing, so the torque is reached 4.6 Newton meter. You can write in kilonewton meter also. Then 4.6 into 10 to the power of minus 3 kilonewton meter. Okay. So that is the only thing is given and remaining dimensions are given in the figure. So you can say diameter of the soil plug which will form when you rotate. So that is equal to 50 mm, so 0.05 meter, and then height of the blade is 100 mm, zero point 1 mm, zero point 1 meter. Okay, and this the rod diameter is also given, that is actually not required. Okay, and if we read the question carefully, assuming the mobilization of undrained shear strength on all failure surfaces, I'll tell you what are those failure surfaces. Okay, uniformly. So this the resistance mobilized on the surface of the vane rod, this is the rod, so that is negligible. So there is no need to consider this diameter and all. So next, so going back to the theory of this, so taking one rod and taking the blades. See, when these are rotating, it has to rotate the total soil plug which will form in the cylinder shape. Taking these four parts, it has to go against the surface, it has to resist or it has to fail against the shear strength along this surface of the soil in this direction, also above and below. Above there is a soil, it has to rotate against the soil above it. So this area and bottom area and side surface area, there are two different parts. One is side of the cylinder which will form plus top and bottom of cylinder. These two, these two, the areas which will uh, give the resistance against the application. So now taking this concept, there is a derivation to find out the shear strength from the torque applied at failure. So that the derivation can be found in any standard book. You can go through the Aurora textbook, KR Aurora textbook, soil mechanics. So we'll be getting. So you can divide the total torque will be divided into torque at side of the cylinder and torque at top and bottom of the cylinder. So after deriving, we will be getting shear strength of the soil. Underlying shear strength of the soil will be T by pi into d square h by 2 plus d cube by 6. This is the formula for getting the shear strength value of soil. This is the torque. This is the diameter of the blade. I have shown in the figure. See, this is the diameter. Okay, this is D. This is H. D, you know, H, you know, pi is 3.14 torque which will be applied. Then you will find out the shear strength. But this formula is derived assuming that the total vane shear is well within the soil, well below the ground level. That means total top and bottom are involving in resisting the failure. So in that case, you have to take this. This is total vane shear instrument is inside the soil. So top and bottom are involved. Suppose if vane shear is inserted such that ground level is here, part of the height is above, part of the blade height is below. Suppose I'll draw here only. Suppose if if ground level is this, so this is the new height. Let us say this is h1. Okay, let us say this is h1. There is no top portion, only h1 is involving in the fail. In that case, SU value will be T by pi into d square h1 by 2 plus dq by 12. Here it is. Okay, this is when only part of the blade and bottom are involved. No top is involved. No top portion is involved. So now, as the question is regarding to this formula, so we can use this formula. So write down again that formula is equal to T by pi into d square h by 2 plus d cube by 6, right? So T we know T is 4.6 into 10 to the power of minus 3 kilonewton divided by pi. D is 0.05 square into h is 0.1 to, so 0.05 cube by 6. Let us solve the problem using calcium. 4.6 into 10 to the power of minus 3 divided by pi into 0.05 square into 0.1 divided by 2 plus 0.05 cube 6. The answer is 10.04 kPa. Okay, so going back to the question again, value is 10.04 kPa, which we have got. Okay, so rounded off to the nearest integer, so that is 10. So answer is 10, B. Thank you.